Welcome to Data Structures and Algorithm, the Egg Edition. Today's topic, hash table. A hash table is an abstract data type that maps keys to values in an associative array. This mapping happens via a math function that converts a data string into an integer. Each element in the resulting array has an index, but important, the key which uniquely identifies the data object before hashing is not the index. The index is the hash value, which is calculated from the key by the hash function. Let's see how it works with eggs. All eggs have different colors, which serves as the key of the egg, but the color is not the egg's index. I now hash the eggs with a hash algorithm. Let's simply assume hashing means some math functions do some magic. After the hashing, every egg gets a specific value based on its key. The resulting value is equal to a specific index egg box the egg will be stored in. So the storage location of the egg is determined by the hash value. What storage location do we have? A storage location for hash values equal to 10, another one equals to 20, and another one equal to 30. Let's assume the egg with a yellow key was hashed and the resulting value is 10. So the yellow egg will be stored in the 10 egg box. The egg with a blue key was hashed and the resulting value is 20. So the blue egg will be stored in the 20 egg box. And finally, the egg with the key green has a resulting hash value of 30. So the green egg will be stored in the 30 egg box. What is important? Every time each egg's key is hashed, it results into the same unique value. So the yellow egg would always get a value 10, the blue 20, and the green egg always 30. In the ideal case, each egg gets its own egg box. In this case, there's a unique hash value for each key, as the number of entries is equal to the number of buckets. The relation between number of entries and number of buckets is called load factor. For 3 eggs and 3 egg boxes, the load factor is 3 divided by 3, 1. But different keys can also lead to the same hash value. So differently colored eggs can end up in the same egg box. Let's assume we hash another egg, the red one, and it gets also a value of 10. And the same happens to the purple egg. Now there's one egg box with 3 eggs and 2 egg boxes with 1 egg each. So the overall load factor is 1.66. We have a collision in the egg box 10. For resolving a collision, there are 2 common ways: open addressing and chaining. Open addressing means, in case of a collision, an alternative slot is searched for. This search is done until an unoccupied slot is found. When a fixed interval, usually 1, is used for finding the unoccupied slot, it is called sequential probing. So, for example, the red egg finds a free slot not at the first, but at the second position in the 10 bucket at 11. When the interval between 2 probes is calculated by a second hash function, this is called double hashing. So, for example, the purple egg could then find an unoccupied slot at 14. Let's remove the red and purple egg again and see how chaining works. Chaining means each bucket is independent and has linked lists of entries with the same index. This would mean the value of the yellow egg gets a pointer to the hash value of the red egg, and from the hash value of the red egg, another pointer points to the value of the purple egg. How do you execute operations like access, search, insert, or delete in a hash table? A pure accessing operation in a hash table, detached from key-value pairs of the elements, doesn't work. The complexity for searching in a hash table is, in best case, big O of 1. But worst case, for example, when all the values are stored in the same hash bucket, then searching takes big O of n. Inserting and deleting an element can be best case big O of 1, but when all elements are hashed into the same bucket and index values have to change due to collision, worst case this could impact all elements in the array, which results in big O of n. The space complexity is big O of n. In summary, hash tables are highly recommended when fast searching, inserting, or deleting is required, especially when the number of entries is large and random. They are most efficient when optimum hash bucket size can be calculated in advance. Hash tables are heavily used for sign-up on websites when the user's password is hashed and then the hashed password is stored.